Hey guys, before we start our lesson today, we're going to have a little warm up here. So this was stuff that we did the last time. Here's 3 problems for you to do. Find x in each one of these, and I'll let you pause the video here and try to figure these out, and then we'll go over them. So take a second and write these out on some paper. Okay, so let's look at this first one here. We have a central angle that's 115 degrees, which means its intercepted arc, which is this right here, is also 115 degrees. Okay, now that gives us the central angle, which has the same intercepted arc. Remember, that is always half of this. So I would take 115 and divide that in 2, and that's going to be, what, 57.5 degrees. Okay, and so that's going to be that angle right there. All righty. Whoops. Not what I tried to do. Let's shrink that up a little bit and get that right in there. Okay. So now over here for x, here's what we know. We know that this is a inscribed angle, so this arc over here is 80 degrees. Okay, can I move this? Nope, it's all one piece. I don't like the way I wrote that, so I'm going to do this and move that over here a little bit. Okay, so there's 80 degrees. Okay, now this is obviously half of a circle up here, so the whole thing will be 180 degrees, so this is going to be 100 degrees, so that one was pretty simple. Okay, this one here, a little bit more complicated. Okay, so I've got an inscribed angle. So the arc from here around to here is going to be twice this. It's going to be 144 degrees. Okay, and then this part of it's 95. So we're going to take 144. We're going to subtract 95 from that. And that's going to be 49 degrees. That's going to be that x right there. Okay. Got a couple more problems here for you. So take these two and pause the video and then find x in each one of these. Okay, so let's take a look at this one here. This is 18 degrees, which means this is an inscribed angle, so that means that this arc right here is 36 degrees. This arc right here is obviously 180, so 180 minus 36 is going to be 144. That's going to be this arc over here. Okay, so now the whole circle is 360. Okay, we've got 180 on this top part. We can go ahead and get rid of that. And we've got 99 over here. We're going to get rid of that. So that's going to be, 81? That's this arc right here. And that means this is half of that. So this is going to be 40.5 degrees. And actually, now that I think about it, I kind of took the long way to get in there. So I could have just said, hey, the bottom half of this is 180 degrees. There's 99. So that leaves 81 for this one. Okay. ABCD is a rectangle. Find x. Okay. So here's the thing. That's a 90-degree angle. That's a 90-degree angle. All these are 90-degree angles. They're all inscribed angles. Okay. So that means that it's 180 from here around to there, because that's the intercepted arc. If I extended this here and here like that. Okay, so we've got 180, and then I've got 136 right there, and I'm going to get, 44 degrees? So this is 44 degrees right here. Piece of cake. All right. I got 2 more here for you. Go ahead and pause the video and then jump on these 2 and then jump back on and see how you did. Okay, this one here is pretty tricky. All right. So here's what you're going to do with this one is this is the point of tangency right here. Okay. And so we are going to draw this. Okay. Now, since that's a radius and that's to the point of tangency, that means that's a 90-degree angle right there, which means that if this is 30 degrees, that angle right there has to be 60 degrees. That's a central angle, which means this arc right here has to be the same as the central angle at 60 degrees. Okay, QRST is a kite. Find X. Okay, so we had a theorem that said if you had two chords that were equal in length, then their intercepted arcs were also equal in length. So if that's 152, that's also 152. And then, of course, the whole thing is a 360. So if I take away 152 twice, that's 304 degrees. That's going to leave 56 degrees, which these two chords are the same length. So they're going to be equal in length. So I'm going to take that divided by 2. They're each going to be 28 degrees. So that's 28 degrees, and that's 28 degrees. Okay, so hopefully you got all those. All right, let's look at arcs and angles here. So the inscribed angle theorem, we talked about this before. The measure of an angle inscribed in a circle is 1/2 the measure of the central angle. So we've actually figured this out in the warm-ups, but this is actually a theorem. Okay, both of these have the same intercepted arc right here. Okay, so if this right here, let's see, if this angle right here is x degrees, that means this arc is x degrees. And that means that the central angle that goes with it is going to be 1/2 x degrees. Okay? So that's a pretty easy theorem to get. All right, inscribed angles that intercept the same arc have to be congruent. Okay, so obviously on this one, if this is x degrees right here, that means that this arc, as its intercepted arc, has to be twice that big, so it's 2x degrees. And then this one would then have to be half of that because it's the same intercepted arc, so it would be x degrees, so these two end up being equal. So a pretty simple little lesson or theorem right there. All right, an angle inscribed in a semicircle is blank. Okay, well, it's an inscribed angle, and if this is a semicircle, this must be 180 degrees right here, which means this must be half of that, which means it's 90, which means this is a right angle. Also a pretty easy one to understand. The opposite angles of a quadrilateral inscribed in a circle are supplementary. Okay, so here's the thing. What they're saying here is that angle R plus angle S has to equal 180 degrees. And we're also saying angle T plus angle U has to be 180 degrees. Okay, well, why is that? Well, here's the thing. If I just take R and S, if I look at those, if I extend this side right here and this side right here, okay, then my intercepted arc is this part of the circle. All right, now, if I extend this side right here and this side right here, that means that this part of the circle is going to be twice this angle right here. Okay, or that means that that's the intercepted arc. Okay, so now the two together, the two intercepted arcs together make 360 degrees. Okay, now it doesn't matter, this yellow one is a little bit bigger than the blue one. Okay, But together they're 360, and since the inscribed angles are half of that, this is going to be half of the blue one, okay? And this is going to be half of the yellow one. And that's going to be half of 360 or 180 degrees. So they're going to be supplementary. And I can do the same thing with T and U. Okay? All right, theorem. Parallel lines intercept congruent arcs on a circle. Okay, so what they're saying here is that if these are parallel lines, and I should mark them as parallel, then the intercepted arcs, so this arc and this arc, have to be the same length. Not going to prove that this time. We'll come back to that. Okay, so something to know right there. You got parallel lines. They go through a circle. They cut off two equal intercepted arcs. Okay, here's your assignment. I'll let you have fun with that, and I will talk with you later.